our team member. First is Nurul Izwani binti Saharudin. Second is me, Ain Hidayah binti Aswadi. And third is Anis Nadia binti Mat Sarif.
Assalamualaikum and hi, my name is Nurul Izwani binti Saharudin. My metric number is 2110327700. Today, our group would like to present about our project. So this paper discusses a 3-stage CMOS operational amplifier design to achieve high gain and good frequency response. As CMOS technology scales down, the traditional amplifier design struggles with reduced gain and output swing. So I will explain about the circuit. So this circuit consists of 3-stage amplifier. The first stage is a differential amplifier using transistor M1 to M5, which help in amplifying input signal. For the second stage and third stage, use a common source configuration to further amplifying the signal. The final stage include a CMOS driver for better output performance. For the DC characteristic, the amplifier shows that it can swing close to both ground and power source. The transfer characteristic indicate the amplifier can handle a wide range of input signal without distortion. And lastly, it is useful for application requiring high gain and ability to drive larger capacitors. Thank you.
Now, I will explain about transient. Transient response is how a circuit behaves temporarily when something changes suddenly, like switch on or off, a power supply, or changing an output signal. It shows the circuit journey from the start conditional state, to its final stable conditional ready state. We have a few key points like sudden change in a circuit, such as turning it on or off, changing input voltage or current, or experiencing the power surge, can cause transient behavior. During this time, the circuit reacts and adjusts to the changes, often displaying phenomena like capacitor charging or discharging gradually, or an indicator resisting repeat change in current. This transient period lasts until the circuit reaches a stable state known as steady state. For instance, when the input signal represented by green curve, which is V in 1, is applied to a circuit, the output, yellow curve, equal to V out, typically show a lower amplitude, gradual decay and some delay compared to the input. This behavior highlights how the circuit attenuates in the input signal and reflects the influence of its internal components. Gain is the measure of how much an amplifier increases the strength of a signal. It is the ratio of the output signal to the input signal and typically expressed as an dimensionless number or in dB. The key point is gain refers to the measure to how much amplifier and input signal. They are the different type of gain, which is voltage gain, which is the ratio of output voltage to the input voltage. Second, current gain, the ratio of output current into the input current. And lastly, power gain, the ratio of the output power to input power. Gain is typically unitless when expressed as a ratio. The graph of gain versus frequency can reveal important detail about the circuit behavior. For the example, blue curve illustrates how much gain decrease as frequency increase, a characteristic of a low-pass filter. Meanwhile, the orange curve shows increasing phase lag with frequency. This curve help analyze the filter ability to attenuate unwanted high frequency while preserving signal quality at lower frequencies.
Okay, next I want to explain about the phase merging. Phase merging is a critical parameter in control theory and electronics, particularly in the analysis of feedback systems such as operational amplifier. First, we can discuss about stability indicator. It is about a higher phase margin indicates a more stable system. Second, for side impact on performance, a higher phase margin usually result in a slower response time. Third is about the measurement. A phase margin of 45 degrees is often considered a good balance between stability and responsiveness, while a phase margin of 60 degrees or more is generally preferred for robust stability. Okay, last for the conclusion. First, the conclusion of the paper highlights the successful design and simulation of a novel 3-stage CMOS operational amplifier that effectively address the challenge of high gain and phase matching while driving large capacitive loads. Second, in the design of the amplifier, especially multi-stage amplifier like the one discussed in the paper, achieve a sufficient phase matching is crucial to ensure that the amplifier can handle variations in a load and maintain stable operation. Thank you.